Alright, so in this lesson we are factoring polynomials. So we've been factoring quadratics, so that just was, the highest term was x squared. So now we're going to have, our highest term will be something different. So we're going to figure out how can I factor these. So our learning targets is I can factor sum and difference of cubes, and I can factor polynomials using quadratic technique. And quadratic technique just means it's the same method that we did quadratics with. Okay, so first we have a list of steps. This is what you always would want to ask yourself to know how to factor these. The very first thing is always ask yourself, is there a GCF? And if there is, then you're going to factor that out first. Then you look and you see how many terms you have. Do you have 2 terms? If so, look to see if it's the difference. So is it subtraction, and is both of the terms perfect squares? If so, then you're going to factor using the difference of squares. If it's not, then you look to see if they are both perfect cubes. If they're perfect cubes, then you will factor using either the sum or the difference of cubes, and we're going to go over that. And then, but if it's not 2 terms, it'll be might be 3 terms. So if it's 3 terms, you're looking to see if it's in the form. Okay, it's not going to be ax squared plus bx plus c, but it might be in that same form. It just may be ax to the 4th bx squared. You see that whatever the exponent is, and it may even be fractions, but whatever your exponent is, the highest one, it should always be twice the amount of your middle term. Okay, and so that way we use either easy trinomial or AC, depending on whether A is 1 or not. And then if there's 4 terms, of course, we can only factor by grouping. And then once you've factored, this is the thing with polynomials, once you've factored, you got to go back and look at every one of those factors and see if you can factor it again. Okay, so let's start with the sum and difference of cubes. So we know that the difference of squares, if I had a squared minus b squared, then my factors is a plus b and a minus b. So this is the difference of squares. And you should have seen the sum and difference of cubes from our polynomial identities. So if both of them are perfect cubes, so a cubed and b cubed, then what you want to do is take the cube root of both of those. So take the cube root of a cubed, you get a. So your first factor is going to be those cubed roots added together because it's with a plus. So with a minus, you're going to have just those 2 roots, cubed roots together with a minus because it's minus. Okay, so that's your first factor anytime you have perfect cubes. Just take the cubed root and whatever sign's in between them, keep it. Okay, and then the next step, you're going to square the first term, so square a squared, so on both of these. Then you're going to multiply a times b and change your sign, okay? So a times b here, we get a positive ab, so I'm going to change that sign. And then your last term is just square the second term. So the only thing that's different is that middle sign. It's always your first and last term is going to be positive because you're squaring it. But the middle one is going to be opposite of whatever your original is. All right, so let's look at a couple of examples. So example 1, I can see x to the 3rd. That's a perfect cube. And 8 is a perfect cube. That's 2 cubed, okay? So x cubed, so this is like x cubed plus 2 cubed, right? I know that 2 cubed is 8. So my a is x, my b is 2. So this would be a plus 2. And then I'm going to square the first one, a squared, multiply them together and change the sign. So minus 2a, and then square the last one. So 2 squared is 4. And that would be, and then you check to see if you can factor again, but we cannot factor this trinomial because there's no factors of 4. When we add, we get negative 2. Okay, so now we look at example 2. And these are not perfect squares. I know that perfect cubed, x cubed is, but not 2x cubed. But we can factor out that 2, and if I divide everything by 2, then those are perfect cubes. So the cubed root of x to the third is just x. The cubed root of 125 is 5. So 5 cubed is 125. So remember, I put those together, keep the sign, and I'm just going to bring down my factor, my greatest common factor. And then for the second one, remember, I want to square the first term. So I get x squared, multiply them together, so I get 5x and change the sign. So plus 5x, and then we do know 27 is a perfect cube. X cubed is a perfect cube, and 1 is, because 1 times 1 times 1 is 1. So 27 is 3 cubed, okay? So let's take the cubed root of both of those, and then 1 is 1 cubed. Okay, so we have 3x plus 1, so that's the cubed root of both of those. Now we got to square the first term, so 9x squared. Remember, I'm squaring everything. Multiply them together, you get 3x, and then you're going to change the sign to a minus, and then square your last term. And that's it. That's how you do the sum and difference of cubes.